Hi, welcome everyone. Thanks for the opportunity again to talk at NLP Summit and give an overview of what we're doing at Sorcero. Sorcero using NLP on the medical insight management. So my name is Jayant Thomas. I go by JT. I'm Senior Director of AI and ML Engineering at Sorcero. I would like to start with a brief introduction about myself and the company, and then we'll dive into the medical insight management application and how we're doing ontology tagging, which is a core NLP construct in MIM, and also go through some of the AI platform architecture and MIM demo, closer to the MIM demo. Sorcero is a startup. It's been in the industry for the past 4 years, 4+ years. We have deployed the software in almost 4 out of 5 life sciences companies like Pfizer, Jensen, and all those leading vendors, J&J and other companies. We have installed our software. Our core software is called as language intelligence. It involves 2 different spaces. One is intelligent publication monitoring, which we monitor different publications. The other one is medical insight monitoring management. How do we manage the medical insights? So I'll go through an overview of that as well. So we are around 50-member team, 50 or 60-member team. Engineering itself is around 40-member team I'm leading. So let me start off with a quick overview of what is medical insight management. One of the biggest challenge we have with the medical affairs, the customer need to manage a lot of unstructured data and build out evidences to get insights about how the product is performing and what are the goal of the product initiatives. So at Sorcero, we built out this platform completely end-to-end SaaS application, what we call this vertical SaaS application, targeting the space, and we can ingest disparate content into a single normalized data set, and then once it is ingested, we'll enrich the data through various different AI enrichment engines into topics, themes, and other assets. So then it allows you to effectively search, filter the content, and sort of using our powerful workflow service we have built, you can create something called as strategic imperatives and build out these collections of key topics, and then create also recommended. AI also builds out recommended collections of potential content as well. Using that, you can create your collections. That's sort of a quick overview, and we use NLP at the core of these functions in very different areas. And I'm going to cover one of the specific areas called ontology tagging. Like I said, I'm going to cover the core construct of what is ontology, how we're using ontology tagging in MIM, and walk you through some of the models we have built out using Spacey as well. So what is ontology? It's essentially a formal specification, of a concept shared in the community. So the vocabulary is a set of things, defining set of things, and its relationship that as it exists in the worldview. And also it gives you a formal way of communication between the application systems. And common format we used is OWL ontology, which is a format, industry standard format. We're using that to build our ontology. An example I can give you is, like you can see here, Matthew, and he's a person, of the type person, and he has a pet called Fido and Fluffy. That's a pet is a type, and the relationship is also marked here. Matthew has a pet, Fluffy, as well as he lives in this country, England. So you can see here how ontology, using OWL, I can define a person. I can say Matthew's this person, of the type person, and he has got a pet, and he lives in, a country called as England. And also you can define, I mean, this, you can imagine it's a hierarchical, you define a concept and it's very hierarchical in nature. You can also use a flat sort of definition of ontology. Essentially, you can have a ontology, like, say, for example, like lungs, and then you can put a lot of synonyms, what is like different medical terms, so that you can also use a hashed version of it. So I'll just go through some of those things in this, in how both of these compares as well. So then we're talking about what is ontology tagging. Ontology tagging is nothing but you have this large corpus of text, and you define your ontology either using a flat hierarchy, a flat structure, or a hierarchy, and then you use AI to sort of tag it, and so that you can basically identify, different, if that ontology exists in this corpus of text, as well as it helps you with doing like different dimensions of searches, and you can use that search functionality to sort of create intelligent collections, which can be shared with the company as well. So you can see here, yeah, you can basically tags are text. Think of tags as textual labels, and then you're sort of searching that within the long, text, format, and it's basically tagging uses ontology terms. And you can see here the ontology is defined, an example I have given is you have disease states, different diseases, and treatments. All these things are related to each other. You can have different concepts here, and you can see the relationship here between the diseases as well as defined in all ontology. Yeah, further driving down the example, here you have the corpus of text defined, so I'm saying, hey, tag this with a given ontology. So I have already uploaded a disease ontology here. I can show you the example here. In this case, the left side is basically is hash ontology, which has got a hash table and the synonyms. So you can see here, it matches all those diseases. It doesn't build out the relationship. So it's got one concept, and there's no relationship between these things. In the right hand side, I've given you ontology with hierarchy, and you can see here it's nicely curated with hierarchy and color coded, and it can derive multiple concepts, and it can build the layers of ontologies as well. So I'm going to focus on both these items and how it compares, how we implement it as well using AI. So how do we sort of build this out? So we used obviously define your ontology using OWL, or using the basic semantic hash table format with tags and synonyms, and then so typically we use Spacey to build this pipeline. You can see here, Spacey as a general pipeline where you can build taggers, your parsers, and your other layers, and then build this NLP pipeline. You pass the text, and then the output comes out with all the tagged elements. And then also the final piece is you need to display that in a workflow and then scale it up in an AI platform. So I'm just going to talk through all of those things. Yeah, I'm going to just dive into the pipeline of the NLP, how we're going to build these pipelines, how we're going to train using the Spacey models. So we're using, as I mentioned in the previous slide, we're using the Spacey pipelines. So we start with an OWL ontology, which is defined using the OWL format, which is hierarchical in nature, and we also have optional, training data for advanced disambiguation. You want to disambiguate, further concepts, we can use that to train as well. So the first step is a tagger. The concept tagger translates the OWL concept into rules for tagging. So that's sort of the first step, and encapsulates and improves the current tagging process. Once the tagging is done, we go through the knowledge base linker, where It takes the textual, mentions found in the tagger, and then try to correlate that to with the disambiguation steps. This particular step is trainable and allows for enrichments and disambiguation of similar mentions in the previous step. And then the next step is the data linker. The data linker brings relevant data from knowledge base into the pipeline and adds these functionalities into the downstream task. And then the final processing is additional processing. This can be used for, say, rule-based, non-literal string-based capturing. And then we finally store these models and then used in the inference pipeline. So we essentially train these models for each OWL ontologies, and then once it is trained for each OWL ontologies, you can then ensemble it. If you want to have multiple ontologies in parallel, you can ensemble the same pipeline as well. So you can see here, the next one just gives you an idea on how we do. We build the ontology using web Protege, and then create the OWL ontology, and then so we run it through the tagging pipeline, we also have. Okay, sorry. Yeah, so we run it by the. So in this slide, I'm just going to you can see here we're building the ontology using web Protege, and then sort of running it through the OWL ontology pipeline, and we can do the same thing with the hash table ontologies we have built earlier as well. And the output is you can see all the tags correctly formed, and then you can see the concept hierarchies also defined in the OWL-based ontology, whereas in a regular synonyms-based ontology, you're not seeing that relationship and the concepts tags as well. So I'll just walk you through some of the architecture we have built, as well. So in this case, so all these things require a lot of horsepower to scale and run. So we, example we have given is, so we're using Dataproc from GCP, so where we run these algorithms at scale. At the left, our software stack is built using a set of series of microservices. So I have on the left is the ingestum microservice, which basically handles all sort of data ingestion and data cataloging, and then we normalize the data. In the ingestum normalizes the data format, and then we run it through the AI pipeline we have built at scale using Dataproc jobs, and then the final output is stored. The relationship between tags and the text is stored in a data store, feature store as well, and then finally we visualize that using the AI. And then all these things are orchestrated at the top by you can see by the workflow, like an Airflow tag, which orchestrates all these different microservices and across the different teams. So now I'll walk you through a quick demo of the MIM as well. You can see here, so I'm in the MIM application. It's a complete multi-tenant SaaS application. You can see the list of records that's ingested. And you can then do all sort of filtering using ontologies, we have built, and also other functions like dates and other things you can do as well. So you can then, you can see the details of a record. You can see here, you click on it to get the details. I can then create a collections. So you can see here, I can do some search and create a set of collections. I'll just dive into one of the collections. It gives you a heuristic, nice dashboard on what the collection is made of, different types of tags. We have defined different types of concepts we have defined. And you can see the tags here highlighted, in this case, capacity, is fluorescent. It's a term we have defined in the OWL ontology, and it's highlighted here. In addition, we provide various different dashboards in the application. You can basically, see slice and dice based on ontologies and other tags you have defined, giving you some examples of ontology safety tag. So what are the types of tagging I've noticed in the data I ingested? You can slice by safety, different ontology. In this case, I showed by disease states, like, what are the different diseases I'm finding in the data set. These are valuable information you can use to build out your story, like understand how the medical insights, like, about like the details about the medical insights for your organization. And a big thank you for the opportunity, and hope you enjoyed the details about how we're doing ontology tagging at Sorcero. For any further questions, do reach out to me in LinkedIn or through email as well. Thank you so much.